Welcome to the last unit of the year. We're going to finish up by talking about circles. Today we're going to look specifically at tangent lines. Now, a tangent to a circle is a line that intersects the circle in exactly one point. So line AB is tangent to circle O at point P. That's considered the point of tangency where they intersect. Now, one of many theorems that we're going to have throughout this unit says that if a line is tangent to a circle, then the line is perpendicular to the radius at that point. So radius OP and line AB are perpendicular and make a right angle. We can use that theorem to help us find the measures of various angles. For example, if segment ML and MN are tangent to circle O, well, that tells me that I have a right angle here and a right angle here. That helps me find the value of x because I have a quadrilateral, and I know that all the angles of a quadrilateral have to add up to 360. So if I add together the three that I have plus x, set it equal to 360, I can now solve and find the value of x. 90 plus 90 plus 117 is 297, plus x equals 360. Subtract 297 from each side, I get x equals 63. Now in this second example, ED is tangent to circle O, which means I have a right angle at D. What is the value of x? Well, I have a triangle, and we know that all three angles of a triangle have to add up to 180. So I can do the same thing. 90 plus 38 is 128. If I subtract 128 from each side, I get x equals 52. We can also use this idea of perpendicular intersections to help us find the measures of the radius. In this example, I want to find the radius of circle C. Well, I have a right triangle, which means I can use the Pythagorean theorem. Now, instead of just writing a squared plus b squared equals c squared, which is our Pythagorean theorem, I'm going to write it a little bit differently. Segment AB squared plus segment BC squared equals segment AC squared. And that helps me identify which numbers I'm going to put in. AB is 12, BC is x, and AC is actually a combination of x plus 8. So 12 squared is 144 plus x squared. And if you don't remember how to square a binomial, remember we can use the FOIL method. Multiply our first terms, so we get x times x is x squared. Multiply our outer terms, so we get 8x. Our inner terms are 8x, and our last terms are 64. So combine our like terms, we get x squared plus 16x plus 64. So if we write that over here, now I want to get all my x's on one side, all my numbers on the other side, so I'm going to subtract x squared from each side. And I get 144 equals 16x plus 64. I'm going to subtract 64 from each side. And I have to carry it over here because I ran out of room. So 144 minus 64, we get 80. Equals 16x, divide both sides by 16, x equals 5. So the radius of circle C is 5. Now what about the radius of circle O? Same idea. So we're going to have 10 squared plus x squared equals x plus 6 quantity squared. So we have 100 plus x squared equals, if we FOIL this out, we get x squared plus 12x plus 36. Subtract x squared from both sides, I get 100 equals 12x plus 36. Subtract 36 from each side, we get 12x equals 64. Divide both sides by 12, we get x equals. Now 64 over 12 will reduce to 16 thirds, or we could write it as a mixed number of 5 1/3. Either way, do not change it to a decimal because it's a repeating decimal, so we want to keep it as a fraction to preserve the actual number. Now, I told you we were going to have some more theorems, so here's some more theorems. The converse to the first theorem states that if a line is perpendicular to a radius at its endpoint on the circle, so line AB here is perpendicular to radius OP, then the line is tangent to the circle, so that tells me that AB is tangent. So that's a way to test if I have a tangent line. In addition, if two tangent segments, in this case AB and BC, share a common endpoint outside the circle, so that would be point B, then the two segments are congruent. Okay, so let's see how we can use those in some problems. In this example, I want to know, is ML tangent to circle N at L? All right, well, if it is, then this would be a right angle. If it's tangent, that has to be a right angle. And if that's a right angle, then we have a right triangle. Well, we can verify that. So what we're going to do is check to see if this actually fits our Pythagorean theorem. Okay, so 25 squared is 625. 24 squared, we get 576. 7 squared, we get 49. 576 plus 49 is 625. Since these two numbers are equal, then yes, segment ML is tangent to circle N. At point L. Okay. Now, using this same diagram, if NL was 4, ML was 7, and NM is 8, is segment ML still a tangent? Well, again, we're going to check with our Pythagorean theorem. Now, NM is our hypotenuse, so NM, they give us a value of 8, so we get 8 squared. And then for our other two values, 4 squared and 7 squared. 8 squared is 64, so we've got to check and see if we get 64 over here. 4 squared is 16, 7 squared is 49. I add those two together, I get 65. Well, last time I checked, 64 does not equal 65, so ML is not tangent. It is not a tangent to circle O. Okay. Now remember, we talked about if we have two tangents that share an endpoint outside the circle, then they're equidistant. So I want to find the perimeter of triangle ABC. Well, these tangents here share endpoint A, so that means they're congruent. These two tangents share endpoint B, so that means those two parts are congruent. Same thing down here. So I can fill in some missing information. I know this is 10. I know this is 8. I know this is 15. So to find the perimeter, I simply add all of those together. 10 plus 10 plus 15 plus 15 plus 8 plus 8. So we get 20 plus 30 plus 16. 50 plus 16, we get 66. Our unit is centimeters, so we have 66 centimeters. For this problem down at the bottom, if the perimeter of triangle PQR is 88 centimeters, what is QY? All right, we got to find out what QY is. Well, it's going to be the same as QX, whatever that is. I know that PZ is the same as PX. I know that ZR and RY are the same. So if I add everything together, and I'm going to call these X because I don't know what they are, then 15 plus 15 plus 17 plus 17 plus my two unknowns equal my perimeter of 88. Okay, well, let's add these together. I get 30 plus 34 plus 2x, so that's 88. 30 plus 34 is 64 plus 2x, I get 88. Subtract 64 from both sides. 2x equals 24. Divide both sides by 2. X equals 12. So the length of QY is 12. Okay. That begins our discussion on circles and talking about tangent segments.